Alright, welcome to this next video. We're going to be talking about the unit circle and trigonometry. Now your learning goal for this one is that students use trigonometry to find unknown sides of right-angled triangles. And at the end of this video and exercises, you'll want to be able to understand the relationship between trigonometric functions and this thing called the unit circle, and calculate the sine of theta, the cosine of theta, and the tangent of theta. All of those things might seem crazy right now, but they're about to make a lot more sense. Okay, what is your approach vector? So you might have heard this before, this idea of a vector. Now, trigonometry has so many applications, and one of the biggest ones is being able to break things down from more complicated directions into the different bits and pieces. Okay, so let's say, for example, a classic question for physics is we're going to be throwing a ball over, and we're going to be throwing it at 45 degrees to the ground, and at I don't know, 20 meters per second. It's probably pretty fast, but anyway, so we're throwing it 20 meters a second at 45-degree angle, and so you want to think, how long is it going to take to get it into the bucket over here? Okay, so the ball's been thrown. How long is it going to take to get over in the bucket here? Now, funnily enough, it's got nothing to do necessarily with this 20 meters a second. You can't just use that. Let's say, pretend we know that it's 100 meters away, okay, and throwing a 100-meter ball into a bucket. Anyway, it doesn't have anything to do with the up speed. It's only the across speed that we care about. Okay, so this is a vector. It's being thrown at this direction of 45 degrees at this particular speed. But what is its, so velocity is equal to 20 meters per second. But what about its velocity in the x direction? Okay, because that's what we care about. If here was our x and our y. Okay, what is the velocity in this direction only? We can use trigonometry to break that original vector down of 20 meters a second at 45 degrees to find out how fast it is at 0 degrees along the x-axis. Okay, so that's one of the main applications in physics of trigonometry, breaking these things down. Okay, but first I want to sort of show another way that we can sort of relate to these things. All right. Key ideas. This thing called the unit circle. It's a circle which is constructed on a Cartesian plane. So we have our x-axis here and our y-axis here, and it's centered at 0, 0. So here is 0, 0 there, and it has a radius of 1. So what that means is if we project a line from here out to the edge of the circle, that's going to have a length of 1, because here is 1, 0. Here is 0, 1, here is -1, 0, and here is 0, -1. Okay, so all the different points around the Cartesian plane like that. Okay, now the three basic trigonometric functions, sine theta, cosine theta, and tan theta. Okay, so we sometimes say sine, cos, and tan for those. All right, now they can be demonstrated on this unit circle. We're going to see how that works. Okay, so we'll project a line out from the center up to the edge here, okay, and we've rotated around from here some angle, theta. Okay, now theta isn't the only angle, it's just one that's basically used for angles initially, and then there's a lot of other Greek letters you sort of tag on as well, but theta is a pretty good one to start with. So theta, it's been rotated around from this point here, from the x-axis, theta degrees, okay, x, y, okay. Now, if we come from here and we're going to project down, drop down from here, perfectly a right angle, what have we got? You might be able to see this. We have here a right angled triangle, okay, on the edge there and there. So we have a right angled triangle here now. Okay, now for this angle, this length, okay, this length between here and here, this is known as the sine of theta. Okay, so this length is the sine of this angle here. Now sine comes from sinus, which is a bay in Latin, so it's like the opening of the angle. Okay, so it's the opposite side from the angle is the sine. Okay, now this length here, do a different color, this length here, between here and here, this is the cosine of theta. Okay, so from here to here, so the x part of our line drawn up here is the cosine of theta. So it's the corresponding side to the sine. That's why it's called the cosine. All right, now the other one, the last one, the tangent. So a tangent, if you may be aware, is a line that comes along and just touches at the side edge of a circle. So if we got a line and just touched the circle like this, okay, and it's going up perfectly at 90 degrees here, and if we extend this line out to here, this distance from here down to the x-axis here, this is known as the tangent of theta. Okay, so when your calculator is doing these functions later on, what it's actually doing is thinking about if we reduce the length of whatever you're doing with your triangle down to 1, because remember this is 1, the sine of theta will be this distance here. Okay, cosine is this part here, tangent is this part here. Okay, so you can see that as this angle changes, okay, if we were to draw a different line going through over to here instead, you'd see that for that smaller angle, the sine of that angle would be smaller, but the cosine would be larger. Okay, so they're really related and intrinsically linked together like that. Okay, now that's how those three functions are related to the unit circle. All right, now the trigonometric functions themselves can also be applied to our right angle triangle. So I've gotten rid of the unit circle and now I just have the right angle triangle. Okay, now the sine function, okay, so the sine of theta, if you're asked for the sine of theta, remembering here's our theta, here's our angle, okay, sine of theta is the opposite over the hypotenuse. So remember the long length of a right angle triangle, this is our hypotenuse. Okay, this is the opposite side. Okay, so the sine function, the sine of this angle is equal to the opposite length divided by the hypotenuse length. Okay, the cosine function, the cosine of theta is equal to the adjacent over the hypotenuse. So the adjacent is the length next to the angle that isn't the hypotenuse. So this would be the adjacent. Okay, so the adjacent line here, so the cosine is the adjacent divided by the hypotenuse, and the tangent is the opposite divided by the adjacent. Okay, so we're going to sort of see how that plays out with a triangle with some actual numbers. Okay, but these are really important, these sine, cosine, tangent. Now there's something special called a that will help you, called a mnemonic. Okay, a mnemonic, M-N-E-M-O-N-I-C, is sort of like a memory thing to be able to remember. Okay, so a mnemonic for this is, so because we've got sine is opposite over hypotenuse, we have S-O-H, sine opposite hypotenuse. Cosine adjacent hypotenuse. Tangent is opposite over adjacent. So SOHCAHTOA. Alright, I learned that when I was at school as something to be able to remember. Sine's opposite over hypotenuse, etc. Okay, that's the kind of thing that you totally write down on your on the top of your test paper as soon as you're allowed to start writing all over it. Okay, so it's one of those little things that in the middle of the exam you don't want to think, oh, what's cosine, what's cosine. So SOHCAHTOA kind of thing. Okay, so it's just one of those things that just get buried in your mind somewhere. Okay, let's have a look at it working with an actual example. So here is theta, okay, and we're going to make our nice little 3, 4, 5 triangle. Okay, so we know 3, 4, 5 is one of those special right angle triangles that work out nicely like that. Okay, so if you were asked to find the sine of theta, remember that's equal to, whoops, the opposite over the hypotenuse, okay, which in this instance the opposite side is 3 over 5, which is the hypotenuse, which is 0.6. Okay, so your sine and cosine numbers are always going to be less than 1. Okay, so if you've got the sine or the cosine of a number of an angle and it's greater than 1, there's something going wrong. Okay, so then if you're asked to find the cosine of that angle, it's equal to the adjacent over the hypotenuse, which is equal to 4 over 5. Okay, and that would be 0.8. And then lastly, the tangent of theta is equal to the opposite over the adjacent, which would be opposite's 3, adjacent's 4, 3 over 4, 0.75. Now, the tan theta can be larger than 1. Okay, so like the tan theta actually goes up to infinity in some instances, so you need to be careful with it, but it can be larger than 1, so don't worry. Alright, so sorry for this video going a bit long, but it's very important that you're able to understand where the trigonometric functions come from. Okay, you're not going to be assessed on the unit circle with this particular content, but it's really important that you understand where they're not just some random things plucked out of the air. Okay, thank you so much for watching, and please come and see me if there's any confusion or misunderstanding with this video at all. Okay, thanks for watching.